March 12, 1943. Pioneer Parachute Company, Manchester, Connecticut. The silk tore with a sound like a gunshot. Adeline Gray froze, her hands still gripping the fabric that had just split along the seam under 220 pounds of test weight. Around her, the cavernous factory floor fell silent. 30 sewing machines stopped their rhythmic clatter. 30 pairs of eyes turned toward the testing rig, where a sandbag-filled dummy now lay crumpled on the concrete floor, 20 feet below the gantry, where moments before it had been suspended by what was supposed to be a regulation T5 parachute canopy. This was the third failure in 2 days. Gray was 41 years old, a textile engineer who'd spent 20 years working with fabrics, wedding dresses, theater curtains, upholstery for Cadillacs. She understood thread counts and tensile strength the way a pianist understands keys. But standing there in March of 1943, watching that dummy on the factory floor represent a real paratrooper who would have just died over Normandy or Sicily or wherever the War Department was planning to send the 82nd and 101st Airborne, she felt the weight of something she'd never experienced in 2 decades of civilian textile work. People were going to die if she got this wrong. The problem was simple and terrifying. Japanese silk, the material that every parachute in the U.S. military inventory was made from, was gone. Cut off. The moment Pearl Harbor burned, America lost access to the silk farms of Asia. The strategic reserve of parachute silk would last maybe 6 more months at current production rates. After that, the entire airborne warfare doctrine that generals were betting the invasion of Europe on would collapse. Not because of German bullets or bad intelligence, but because there wouldn't be enough parachutes to drop the men who needed to jump. Gray walked to the crumpled test dummy and knelt beside it, running her fingers over the torn seam. The fabric itself was intact. This wasn't about the material failing. This was about the construction. The way the panels were joined, the stress points where 200 pounds of human being and equipment would pull against stitching during deployment. Silk had a natural elasticity that absorbed shock. The alternatives they were testing, cotton, rayon, even experimental nylon blends, didn't have that forgiveness. They were either too rigid, snapping under sudden stress, or too elastic, deploying too slowly and leaving paratroopers to slam into the ground at lethal speeds. Mrs. Gray? The voice belonged to Captain Morrison, Army Ordnance Corps, the liaison officer who'd been assigned to oversee the conversion project. He was 26, West Point, and had the uncomfortable look of a man who understood tactics but not textiles, watching his mission timeline disintegrate because of something as mundane as fabric. We need a solution. The Joint Chiefs are planning Operation Overlord for next spring. That's 12 months. We need 50,000 parachutes in production by September to meet the training and operational requirements. 50,000 parachutes. Each one requiring 24 panels of fabric, each panel needing specific tensile strength, specific weight, specific deployment characteristics. Each one needing to work perfectly because there were no second chances at 1,200 feet. Gray looked at Morrison, then at her production floor, then back at the dummy on the concrete. "We're approaching this wrong," she said quietly. Morrison frowned. "Ma'am?" She held up the torn fabric. "We're trying to make cotton and rayon behave like silk, but they're not silk. They have different properties, different stress responses. We need to redesign the parachute around the materials we have, not force new materials into old designs." The captain looked skeptical. "Mrs. Gray, the T5 parachute design has been tested and validated. Changing the fundamental design would require retraining, recertification." Gray interrupted him. "And using the current design with substitute materials will require new coffins. Look at this seam. The stitching is regulation. But cotton doesn't stretch like silk. When the parachute deploys, there's a shock load of over 1,000 pounds in the first second. Silk absorbs that. Cotton transmits it directly to the seams. That's why they're failing." Morrison studied her for a long moment. Finally, he nodded. What do you need? Gray turned to her lead supervisor, Helen Kowalski, a Polish immigrant who'd been sewing parachutes since 1940 and had 2 sons in the Army, one training to be a paratrooper. Helen, get me samples of every fabric in inventory. Cotton, rayon, that experimental nylon from DuPont, even the linen from hospital surplus. I need 3 days. Morrison hesitated, then agreed. 3 days, Mrs. Gray. After that, I need results, or I report back to Washington that airborne operations for Overlord aren't feasible. When he left, Gray moved to her drafting table and began sketching. The problem wasn't just fabric, it was the entire system. Panels, seams, suspension lines, harness points. Everything had been optimized for silk. She needed to redesign it all for materials that behaved completely differently under stress. She worked through that night and the next, testing fabric samples on custom rigs, measuring how they behaved under sudden loads, gradual loads, repeated stress. She dissected failed parachutes, studying exactly where and how they broke. She filled notebooks with data, equations, sketches of canopy designs that evolved away from the silk-optimized T5 toward something new. The breakthrough came at 2 a.m. on the 3rd night. She was testing cotton with a modified weave, tighter in some areas, looser in others, creating zones of different elasticity within the same fabric. When she applied shock force, the fabric didn't tear. It stretched. Not as much as silk, but enough. The stress distributed across the weave zones instead of concentrating at the seams. Helen, Gray called out, her voice sharp with excitement. Get the stitching crew back. I need a full-scale prototype by morning. They worked through the night, 8 women operating sewing machines with the precision of surgeons, following Gray's specifications exactly. The new design had 28 panels instead of 24, each one cut at slightly different angles to distribute stress. The seams were reinforced with a double stitching pattern Gray had adapted from sailmaking. The suspension lines attached to reinforced patches that spread the load across multiple connection points, instead of concentrating force at single stress points. By 6 a.m., they had a complete parachute canopy made entirely from repurposed cotton that 3 days earlier had been destined to become bedsheets in a Philadelphia textile mill. Morrison arrived at 8 a.m. to find Gray's team already rigging the test dummy. He looked exhausted, like he'd spent the night preparing the report that would cancel airborne operations. Then he saw the parachute. Is that, he started. Cotton, Gray confirmed. Modified weave, redesigned panel configuration, reinforced stress points. It's not a T5, it's something new. She nodded to her crew. Drop it. The dummy fell. The parachute deployed with a crack of fabric snapping open. The canopy filled, perfectly round, exactly as designed. The dummy swung gently beneath it, suspended by lines that held without a tremor. It descended at exactly 18 feet per second, the regulation rate for safe paratrooper landing. When it touched down, Gray's crew swarmed it, examining every seam, every attachment point, every inch of fabric. Not a single thread had failed. Morrison stared at it, then at Gray. Do it again. They did. 5 more times that morning. Different weights, 180 pounds, 220 pounds, 250 pounds with full combat gear, different deployment speeds, different environmental conditions. They even soaked one canopy in water to simulate rain. Every single test succeeded. By noon, Morrison was on the phone to Washington. By evening, a full colonel from Army Ordnance was on a train to Connecticut. By the end of the week, Gray had authorization to convert the entire Pioneer parachute production line to her new design. But authorization was just the beginning. Now came the truly impossible part: quality control. Gray's design worked, but it only worked if every single parachute was constructed exactly to specification. A seam that was off by 3 stitches per inch could fail. A panel cut 2 degrees wrong could cause asymmetric deployment. A suspension line attached 1 inch off center could create oscillation that would slam a paratrooper into the ground sideways. And they needed to produce 50,000 of them in 6 months, which meant 275 parachutes every single day. Each one perfect. Each one guaranteed to save a life or become responsible for ending one. The military's standard quality control was statistical sampling. Inspect 1 out of every 100 parachutes. Certify the batch if the sample passed. Gray looked at those numbers and did the math. A 1% inspection rate with a 99% accuracy rate meant 50 parachutes out of 50,000 would fail. 50 dead paratroopers. 50 families destroyed because a statistical sample said good enough. She walked into Morrison's temporary office at the factory and told him she was rejecting the standard protocol. "We test every single one," she said. Morrison looked at her like she'd suggested they hand-deliver each parachute to Berlin personally. "Mrs. Gray, that's not feasible. Testing means drop tests. You're talking about 50,000 drop tests, the time alone." 16 seconds per parachute, Gray interrupted. "Pack it, hoist it, drop 200 pounds, confirm deployment, inspect the canopy. 16 seconds. We build a dedicated test facility with 8 drop towers running simultaneously. That's 30 parachutes tested per minute. We run 2 10-hour shifts with inspectors who do nothing but test. We can validate 18,000 parachutes a week." She leaned forward. "And we catch every single failure before it gets loaded onto a C-47 headed for France." Morrison was quiet for a long moment. "That's never been done before, not at this scale." Gray met his eyes. "Neither has an airborne invasion of occupied Europe. We're making it up as we go. The question is whether we're making it up well enough that the men jumping out of those planes come home." The test facility was operational by May. 8 towers, 30 feet high, arranged in a line inside a warehouse that had been manufacturing brass fittings for plumbing 3 months earlier. Each tower had a quick-release mechanism, a weighted test dummy, and an inspection station. Women worked the towers in pairs, one to load and drop, one to inspect. Every parachute that came off the production line went through a tower, every single one. If it passed, it got a stamp and a serial number and moved to the packing facility. If it failed, even slightly, even a seam that was merely suspect rather than obviously defective, it went to Gray's desk for analysis. She personally examined every failure, trying to understand whether it was a one-time construction error or a systemic problem that could affect other parachutes. A bad seam on parachute 3847 meant inspecting the work of that particular seamstress for the entire day. A suspension line attachment that was half an inch off specification meant checking the rigging crew's measurements and retraining if necessary. It was exhausting, meticulous work that made her eyes burn and her hands cramp. But by July, the failure rate had dropped from 3% to 0.2%. By September, it was 0.06%. 3 failures per 5,000 parachutes, each one caught and removed before it could kill anyone. The paratroopers started arriving in England in early 1944. The 82nd Airborne, the 101st Airborne, thousands of men who'd trained for months to jump out of perfectly good airplanes and fight behind enemy lines. They didn't know about Adeline Gray, didn't know about the silk shortage or the cotton bed sheets or the redesigned stress points. They knew their parachutes were marked Type C modified instead of the standard T5 designation, but that was just Army paperwork. What they cared about was that when they jumped, the parachute opened. Every time. No malfunctions, no failures, no stories of training jumps where a guy pulled his ripcord and nothing happened, where he had 15 seconds to deploy his reserve while the ground rushed up to meet him. June 5, 1944. Somewhere in southern England, the 101st Airborne was loading into C-47 transport planes. Private James Chen from Sacramento checked his parachute for the dozenth time. Harness tight, static line secure, reserve chute accessible. The parachute pack felt solid against his back. 40 pounds of fabric and cord that represented the difference between completing his mission and becoming a crater in a French field. He didn't think about where it came from. None of them did. They just trusted it would work. Across the channel, Adeline Gray sat in her Connecticut factory at 11 p.m., unable to sleep, knowing that somewhere over France in the darkness, men were jumping. The parachutes opening above them bore her signature on the inspection logs, not literally, but spiritually. Every one of those canopies had passed through her test facility. Everyone had been certified by her quality control system. Everyone represented her promise that she'd done everything humanly possible to bring them home alive. The reports came back over the following days and weeks. The airborne drops on D-Day were chaotic. Planes scattered by anti-aircraft fire, paratroopers landing miles from their objectives, equipment lost, units fragmented. But the parachutes worked. Out of more than 13,000 American paratroopers who jumped into Normandy on June 6th, the parachute failure rate was less than 0.1%. Fewer than a dozen malfunctions out of thousands of jumps. In previous operations, the failure rate had been nearly 2%. Gray's obsessive quality control, her refusal to accept statistical sampling, her insistence that every single parachute be tested, it had saved lives. Hundreds of them. Maybe thousands, when counting the subsequent airborne operations at Market Garden, the Rhine crossing, the liberation of southern France. She never met any of the men whose lives her parachutes saved, never heard their names or saw their faces. But in September of 1945, after the war ended, she received a letter from the War Department. It was formal, bureaucratic, thanking her for her contributions to the war effort. Attached to it was a list, not of names, but of numbers. Serial numbers from parachutes that had been used in combat, recovered, inspected, and returned to service. Thousands of them. Each one representing a jump where a soldier had trusted his life to fabric and stitching and engineering, where he'd leaped into darkness or daylight or hell itself, and the parachute had opened and held and brought him safely to earth. Gray kept that list in her desk drawer for the rest of her life. She never showed it to anyone, never spoke about it publicly. When people asked what she did during the war, she'd say she worked in a textile factory, helped with production. The truth was bigger and quieter than that. The truth was that a seamstress from Connecticut, armed with nothing but fabric samples and mathematics and an absolute refusal to accept that good enough was acceptable when lives were at stake, had turned bedsheets into lifelines, and proved that genius doesn't always come from generals or scientists or engineers with advanced degrees. Sometimes it comes from someone who simply understands materials and cares enough to get it right, who sees a problem that's killing people and refuses to rest until she's solved it, who works through the night because sleeping is impossible when you know that boys are about to jump out of airplanes and their survival depends on whether you've done your job well enough. The parachutes themselves are long gone now. Used, worn out, discarded, replaced by modern materials and designs. But the principle Adeline Gray established remains. Every parachute in the U.S. military inventory is still tested individually, not sampled, not statistically validated, tested, one at a time, every single one, because she proved it was possible, and because once you've proven that you can test every parachute and catch every failure, accepting anything less becomes unthinkable. That's her legacy. Not a medal or a monument, but a standard. The absolute certainty that when a soldier steps out of an aircraft, the parachute will open. Not probably, not statistically, certainly, because someone like Adeline Gray made sure of it, one cotton bedsheet at a time.